بسم الله الرحمن الرحيم. مرحبا جميعا. في هذا الفيديو سوف نتحدث عن الدوال، تحديدا طرق التعبير عن الدالة. Hello everyone. In this video I will talk about functions. To be specific, I will talk about ways to represent a function. When functions arrays. Functions arrays when one quantity depends on another. For example, the area A of the circle depends on the radius of the circle, R. The human population of the world, P, depends on the time T. The cost of mailing an envelope, P, depends on weight, its weight, W. The vertical acceleration of the ground during an earthquake, A, depends on time T. A second definition for the function f. A function f is a rule that takes each element x in a set D exactly to one element f of x in a set E. And we can write this in a mathematical sentence as follows. For every x belongs to D, there exists y belongs to E, where f of x equal to y and y is unique. Knowing that the function is for every x belong to D, there exists y belong to E, where f of x equal y and y is unique, we can answer two questions. The first question is, what is the domain of the function? The domain of the function is this set D. The second question is, what is the range of the function? The range of the function is the set of all the possible values of f of x as x varies throughout the domain. The other two concepts that are related to functions are independent variable and dependent variable. What is the independent variable? It's the symbol that represents a number in the domain. And what is the dependent variable? It is the symbol that represents a number in the range. According to the both mentioned examples, let's fill in this table. The first example, the area A of the circle depends on the radius R of the circle. So A is the dependent variable and R is the independent variable. The second example, the human population of the world P depends on the time T. So B is the dependent variable and T is the independent variable. Third example, the cost of mailing an envelope P depends on its weight W. So P is the dependent variable and W is the independent variable. The last example, the vertical acceleration of the ground A depends on time T. So A is the dependent variable and T is the independent variable. Example 1. The graph of the function is shown as you can see here. A, find the value of f of 1 and f of 5. So what we will do is going to x equal 1, okay, and then see the graph cuts where at x equal 3. Okay, so f1 equal 3 f of 5, we go to x equal 5, 1, 2, 3, 4, 5. Here is x equal 5. Let's see the graph. It is at approximately minus 1.7. So f of 5 approximately equal to minus 1.7. Okay. F of 1 equal to 3, we can say two mathematical sentence knowing that f of 1 equal to 3, which is the first one that the point 1 and 3 is on the graph. The second sentence is that to reach the point on the graph when x equal to 1, we need to move 3 units above the x-axis. Okay, this is for A. And for B, what are the domain and the range of f? To get the range and the domain, we draw a rectangle around the surrounding the graph. Okay, like this. This is the higher point. Okay, so we draw it like this, and this is the lowest part, and here we go. So what we find that x begins from 0 and ends at, if we complete the counting, 1, 2, 3, 4, 5, 6, 7, and ends at x equal to 7. So our domain is that x is between 0 and 7, and we can write it as a closed interval 0 and 7. Okay, what about the range of the function? The range, we see the y begins from -2 and ends to 4. Okay, ends at 4. So y is between -2 and 4, and we can write this as a closed form, as a closed interval -2 and 4. Okay. Example 2. Sketch the graph and find the domain and the range of each function. A. F of x equal to 2x minus 1. So we have A, f of x equal to 2x minus 1. It is a line equation. In the form y equal mx plus c, where the slope m equal to 2 and c, the y-intercept equal to -1. So how can we draw this? First, we draw the y-axis, the x-axis, and then we start from -1 on the y-axis, c, and then according to the slope, which is equal to 2 over 1, we move 2 steps to the right and then 1 step up. Okay, and then this point is on the line. So this point and this point is on the line, so we just can draw the line now like this. Okay, now we want to find the domain and the range. As I said, we draw a rectangle that surrounded our graph. So when we draw the rectangle like this, okay, we can find that this line grows up to infinity, to directions, the directions of the arrow that we can see here that they are drawing. And that makes our rectangles, according to the x-axis, okay, grow like this to the minus infinity and grow like this to the infinity. So according to the domain, the x is between minus infinity and infinity, i.e. it's an open interval, so we can write it as an open interval minus infinity and infinity, or we can write it r like this, which is what the set of all real numbers. Okay, for the range we will see the rectangle according to y-axis, and we can see it's growing like this to the minus infinity and grows like this to the infinity. So y will take the values from minus infinity to infinity. Okay, and it's the same, we can write it as an open interval from minus infinity to infinity, or the symbol r, which is the set of all the real numbers. Okay, what about b? B is g of x equal to x squared, and it is an equation for a parabola. And we know that we can draw it just like this. Okay, where it intersects the point 0 and 0 and 1 and 1 and minus 1 and 1. Okay, so to get the domain and the range we do the same thing. We draw the rectangle and see what happens. For x-axis, we can find that the parabola grow like this and like this. So the rectangle, okay, grows like this to the infinity and grows like this to the minus infinity. So the x is between minus infinity and infinity, and this is our domain. What about the range? We can see, we will look first at the y-axis and see that it is fixed here from 0. Okay, so y is between 0 and we can see it's growing up like this and like this, taking values from the y to the infinity. So y is between 0 and infinity. We can write this as an half open interval or half closed interval, closed from 0 and opened at infinity. Okay,